Hello, hi everyone. We'll talk about forensics today. My name is Jose Ahirton. I'm a data scientist at Duratex. Duratex is one of the biggest Brazilian industries, mainly working on the fabrication of wood panels, metalware, ceramics, etc. And I'm also a co-organizer, community manager at AI Brazil. We have many members of AI Brazil here today. Thank you. Um, I'm also a teacher at FIAP, at our Artificial Intelligence MBA. And today I will talk a little about my master thesis work. It's entitled A Methodology for Gender Expression and Classification, GENEC. And well, my advisor was Dr. Leandro Nunes de Castro, one of the greatest scientists, Brazilian scientists working in machine learning right now. And my co-advisor was Dr. Rodrigo Passi. And he was at the Renato Archer Center, and we were working mainly with military and with the federal police in Brazil. So it's mainly used for investigation and so on, but I will try to give you examples of another uses of this methodology. And that's my agenda for today. I will give a little introduction, a brief introduction about the subject. It's a little complicated subject, I know, but I think everyone will enjoy it very much. Then I will have my theoretical references. I will talk about the methodology, how I came up with this idea, and then our performance evaluation. For our introduction, we all know that we're having a paradigm shift nowadays. We're coming from Web 1.0, and Web 1.0 um, we're usually we're usually there's usually one vector of news, of information, a journal, a TV, etc. But nowadays, we're giving the power to the people, literally. So people can share, can really make it collaborative. So information is not one to many, it's many to many right now. So in this case, we have our motivation, that's the automatic user characterization problem. And why so, Ayrton? And think about anonymity, think about social media, think about fake news, Facebook, Twitter, etc. You will always have someone that is faking it, that is faking to be you, that is faking to be a famous person. What can we do about it? What can we really do about it? I'm proposing a lot of meta attributes, a lot of characteristics that we can read um, only by text. There are a lot of other researchers that are reading images, reading background information, etc. But hey, if I'm talking about anonymity, if I'm talking about military applications and federal police applications, I'm talking about someone who isn't typing very much, who is a little bit sketchy, yeah? Of course, they're trying to flee the police. Yeah. So I'm talking about anonymous persons who aren't tweeting too much, and I have a sparse kind of text. Yeah? I have little text to work on, and what can I do about it? So I will have many attributes, like 160 attributes that I will be reading from text. And my main goal is to discover if this person is of male gender expression or female gender expression. So, what about gender expression, Ayrton? What is gender expression? First of all, I love text, I love poetry, and I love psychology. So this research is all based in psychology, mainly on the guidelines of the American Psychology Association. And APA, they APA, they say that gender expression is how you communicate your gender in a given culture. So in Brazilian culture, mainly people communicate their gender by their talk, by when they're speaking, or when their mannerisms, or the way they dress, the way they use fashion. So my current architecture was mainly collecting tweets using TweetPy. It's an API, a very famous API using Python. Then I have a database of tweets. Just to give a little bit of spicy to this research, I use it mainly non-gender tweets. So, for example, the tweets of journalists, the tweets of um, news feeds broadcasters and politicians, because they don't usually use gender on this kind of tweet. Because of course in Portuguese we have some words that give gender. For example, ele foi, ela foi, etc. But we have other languages that just don't give any cues about gender. So how can I be generalistic about it? Think forensics, okay? So I have my pre-processing. I'm mainly talking here about part of speech tagging and tokenizing my text, of course. I have to work with little parts of the text, so literally my words. Then I have the meta attributes extraction. I will, if I have the time, I will give a demo about it. Then I have my meta attribute selection, so I'm always feeding new meta attributes. I'm always recurring this meta attribute somehow. Then I have my classification. Here we use it SVM, we use it knife base, we use it decision trees, forward decision trees, etc. You can, of course, I will share my meta attributes class. You can use whatever algorithm you want to. And then we have a result, if male or female. So basically my preprocessing, as I told so, is my tokenization. I give a dictionary and I say, okay, those are the words in Portuguese. This is a verb, this is an adverb, this is an adnominal, adjunction, etc. And then I have, of course, my part of speech tagging that says that's so. I use it MacMorpho. MacMorpho is a dictionary based on articles from Folha de São Paulo. So in 1994, a researcher said, okay, I will tokenize all the words in Portuguese. Yeah, it's a little bit crazy, right? Remember, he did it manually, okay? So we keep on using this because it's a very difficult task. And then we have this. So I have adjectives, adverbs, subordinative connective adverbs, subordinative articles, current currency symbols, etc. Every one of them is treated as a meta attribute. So I have an example of tweet here. William Bonner was very famous on Twitter at the time. So we have, como dizem meus sobrinhos de Twitter, rimos litros, embora eu não entenda como se possa medir o volume espacial de risos, mas tudo bem. So, as my nephews say in Twitter, we left leaders, although I don't know how we can measure the volume, the special volume of laughter, but it's all right. So we have here our part of speech tagging in action. So we have, for example, our verbs, we have our adverbial pronouns, we have prepositions, and of course, we have something that cannot be classified. For example, the names of enterprises, the names of algorithms, etc. But you see that it works quite well. So those are my meta attributes. Yes, 128 meta attributes, all programmed one by one in Python. So I have 16 meta attributes involving characters and syntax. Basically, the total number of characters divided by the total number of digits, etc. I have 28 meta attributes based on words. They're mainly vocabulary richness measures. This is from an area called text authorship attribution. That's a very famous area on an NLP. I won't be talking about much of that. If you want, so I have a class about it, okay? Text structure. So basically, I'm working with the number of question marks, the number of commas, etc. Morphology or how people organize their text. And that's mainly what you see that uh, um, we most distance each other when using both textual structure and morphology. And then we have also psycholinguistic cues. I had to go there and do some dictionaries in Python. So I have emotional dictionaries, for example, Portuguese positive words, negative words, neutral words. I have emoticons, emojis. I have positive emoticons, negative emoticons, neutral emoticons. I have some cognitive markers. For example, there are some psychology studies that says that women tend to use more a word than other. Men tend to be more specific when they talk in social media, etc. So it's all in there. And well, so I have this tweet, and then I have a large vector, as you already know from Word2Vec or working with images. So I have, for example, the number of characters here is 134. I have letter cases and so on. I have the number of digits, the number of white spaces, etc. And well, what's my problem? Well, my problem is to classify a tweet, given this large amount of data, and I have to classify them in male or female using the given number of meta attributes. So basically, the output of my model will be if there is female, if this is a male tweet. Remember, I'm using gender expression, so there's no transgender gender expression. And so, first of all, I used um, think so, almost 200,000 tweets from 60 profiles. And we also investigated the relevance of these tweets, these meta attributes using chi-squared and my information gain. Um, we also used it on 4 machine learning algorithms. They were um, unfortunately, I cannot share them because they're already being used by the federal police. We used functional trees, best first trees, knife base, and support vector machines mainly. I tested other algorithms. If someone wants to know about it, I can talk about it later. And well, those are my results. Uh, Remember, please, that those are tweets that don't give gender-specific cues. So it's pretty amazing that we achieved this kind of rate of accuracy. So, for example, using a tweet-by-tweet metric, so I used a vector for each tweet, so I end up with 3,000 male tweets, 3,000 female tweets. And then we have a precision using, for example, knife base of 61% and SVM 68% of accuracy. And then you see that when we concatenate this, or we take every tweet from this person and we concatenate that with only one text. So we have one text for each person. And then you can see that our accuracy exponentially grows with this kind of information. Because of course, if you have one big text from someone, you can give some little context about it. The algorithms can learn more about it. And then we had 80% of accuracy. of course, there was using k-fold, 10-fold validation, so it's pretty gnarly, this kind of result. And then using more tweets, they're using my psychological linguistic cues, because it was the problem that we were facing. Um, uh, if we use psychology, what will change? Actually, the results were a little bit worse. And so we have a tendency to drop down the accuracy if we have too many psychological, so-called linguistic cues being used. And well, Ayrton, what were the most significant um, attributes? Well, it was pretty good actually. We saw that textual structure is pretty significant for this kind of problem. The number of words, uh, um, meta attributes based on the number of words, etc., were pretty good for our accuracy. And you can see also when we use more tweets, we tend to have other meta attributes being more important. So, for example, we had um, psychological cues being more important with more tweets. So basically, one of the conclusions that we could make is that psychological cues are more suited when you have more information about this person. And well, it was kind of expected, because I can only imagine that is a really hard work for someone from psychology to really understand and to really make a profile of someone with little data. So of course, with much more data, I can be much more specific about psycholinguistic cues. And well, also we tried to do it each meta attribute set each time. So for example, we tested only character and syntax meta attributes, only psychological cues meta attributes, only textual morphology attributes, and then we saw that, well, they don't usually work very well alone. They go well when they're used they're used all the set in. And well, our conclusions are that support vector machines are very good when you have large data sets, but the police is more focusing on using decision trees. It was already used on Olympics. I don't know the details about busts or anything, if people were really in jail because of that, but I believe that it worked very well. We didn't have any complaints. And well, where it can be used, not only for forensics, but for example, there at Duratex, we're using it for targeting recommendation tools. So we have a deep recommendation tools, also done by myself. We're using it in email marketing too. So any contact, any given contact based on anonymity can be now traced, it can be now really profiled. And of course, the construction of user profiles based on anonymous data. And well, this work is entirely dedicated to my brother that passed away, an adventurer who, with his simplicity, taught me to respect the nature of things. Let us respect each other, just as the surfer learned to respect the sea, the wave, the infinite in each other. And now I will give a demo. I have some time? Okay. Não tá indo. So, When I said that we used all the words in Portuguese, I was really serious about it. So I pretty much had to read dictionaries for almost 5 months of my life. So that's basically our psychological linguistic cues. So we have a number of positive words, number of negative words, and we have also other properties, for example, textomorphology ones, the reason between the number of prepositions and total of words. We have the median of words used by a person, and an entropy measure, of course, to share our gain of information, and the total of characters, the number of words, and so on. And those are my dictionaries. And well, let's go one more time to the presentation. Apple is trolling me. So you can have access to this work and many more on my GitHub. My complete thesis is on ResearchGate and SlideShare. Share alike if you can, please. And that's all, folks.